Day 108, Part 3 notes. So, the very first thing that we have here is the map of the globe, and the sunlight is coming in here and heating up the ground, and the ground heats up the air and causes things to happen. Here at number 1, we have air rising. So, the heat of the equator makes air hot and rise. When it comes up, it's going to spread out. The air spreads out. Some of it goes to the north, and some of it's going to go to the south. And it's going to move this way. And then the air cools and sinks. Line number 4, the air spreads out. Some of it's going to go to the south, and some of it is going to sink and go to the north. But here we've set up one circular pattern, a convection current, hot air rising, cool air sinking. Number 4. At 5 here, we have cold air sinking. At the very North Pole, it's very, very cold. So the air there cools and sinks. So we have some air that's sinking here coming south. We have some air here sinking and going to the north. When they collide, they're going to rise up. Colliding air rises. And so that sets up 2 more circular currents there and there. And then we have the same thing in the south. So we have this circular pattern there, and one here, and one here. So we have a grand total of 6 circular currents that go around Earth. And they're like giant donuts. I've only drawn the left-hand side of each donut. But this circular pattern actually is a donut that goes around like this. And then this one is a donut that goes around, and we have the similar kinds of circles on the other side. That gets to be a rather complicated situation, so I'm only going to usually show just the circles on one side. Wes, please put away your phone and let's do the notes, please. Number 8. Where is the air sinking and causing high pressure? Here is a high pressure. It's sinking. The air is pushing down on the ground more than normal. Same thing is happening here. I'm sorry, Alexa, is there a question? Sure. So we have high pressure here. That's where the air is sinking and pushing down. And we have high pressure down there. That's where the air is sinking, pushing on the ground. And again on the very far North Pole. And on the very South Pole. Number 9. Where is air rising and causing low pressure? Right here at the equator, it's rising, so we have low pressure. It's lifting up off the ground. It's not pushing down as much. Here we have the low pressure of rising air. And there's one more spot. One more spot down here. So where air rises, it's not pushing on the ground as much, and so we have low air pressure. Suction cups will not work quite as well down in those places as where there's high pressure. I don't think that in everyday experiences we'd be able to tell the difference, but if you had careful instruments, you'd be able to tell it. The directions of the wind is always from high pressure going away from the high pressure areas. These circle currents have a special name, convection currents or convection cells. the boundaries between these cells move around a bit. They don't stay in the exact same place all the time. So some of these will grow bigger and smaller. They'll shift north and south from day to day. Our model of this convection project is like the real atmosphere because it is a fluid. It can move around. However, it's different because we had water instead of air. On the back side, number 10. In the winds in the U.S. generally go from the west. Oh, I'm sorry. We're going to have to watch this video here before you can understand line number 10. From west to east, because of this. The curving of these winds creates, let's see here, you guys go ahead. I'm going to finish up while you guys go ahead. The curving of these winds creates the jet streams. These are narrow bands of winds in the upper air troposphere. Since the convection cells don't stay in one spot, the jet streams wiggle around. The band of jet streams can block other air masses from moving around. And then you can watch these videos here.